two engines on the overhaul stand. One has a timing chain, the other has a gear train. Every diesel mechanic who has worked on both already knows what the verdict is before they pull the first head bolt. Which side of that argument are you on? The debate about the 6.2-liter Detroit diesel has been running since 1982, and most of the people having it do not know the part that changes the math. The US Army knows it. The farmers who bought those Suburbans did not. And General Motors, the company that built the engine and built the division that built the engine, and then sold that division for $50 million while the US Army was still driving it, spent 40 years making sure nobody connected those threads. This is the full story of what the 6.2-liter Detroit diesel actually is, where it came from, and what General Motors did with the company that built it. The US Army ran 600,000 miles of field evaluation before staking 55,000 vehicles on this engine. Did the mechanics who wrote it off in 1982 get the call right? Subscribe to American Motor Files. This is what we cover. To understand what General Motors was selling in 1982, you have to understand what they were running from. In 1978, General Motors launched the Oldsmobile 5.7-liter diesel into passenger cars and light trucks. It was not a diesel engine. It was a 350 cubic inch gasoline V8, the same block Oldsmobile had been casting for years, with the compression ratio pushed to 2.5 to 1, and an injection pump bolted to the top. A standard diesel uses head bolts engineered for the mechanical stress that compression ignition creates. The 5.7-liter used the same head bolt count as the gasoline version. That arrangement was not built for 22.5 to 1 compression. The results were immediate and public. Cranks broke in half. Head gaskets failed not once, but repeatedly on the same engine, sometimes within 50,000 miles of the previous repair. Injection pump shafts seized from water in the fuel system, water that a standard separator would have caught, because General Motors had not included one, because it cost money on a margin that was already thin. The shops handling warranty work were flooded. By the time a fix arrived, the customers who had bought the diesel option had already decided what American diesel engineering was worth. One of General Motors' own engineers told the New York Times directly, in test after test before production, they had found broken cranks, broken blocks, leaking head gaskets, and failed fuel pumps throughout the development cycle. That engineer was pushed into early retirement for the disclosure. The 5.7-liter went into production anyway. By 1981, that engine had done something years of imported competition could not. It had made American consumers afraid of American diesel. The dealers stopped recommending it. The insurance actuaries noted the warranty costs. Owners who had specifically bought the diesel option for long-term economy watched the repair bills erase 3 years of fuel savings inside the first 60,000 miles. The 5.7-liter disaster did not just damage one product line, it set back the entire case for American diesel trucks by a decade, and General Motors needed a purpose-built answer before the window for diesel in American pickups closed entirely. General Motors handed the problem to Detroit Diesel Division. Why did General Motors go to the one division inside its own organization with actual diesel engineering expertise instead of converting another gasoline block? Because by 1978, it was already too late for another conversion. Detroit Diesel had existed since 1938, when General Motors created its GM Diesel division to build smaller industrial engines from the locomotive technology it had developed a decade earlier. The division's Series 71 two-stroke diesel became the Allied war effort's primary diesel engine inside of 3 years. Approximately 57,000 Series 71 engines powered landing craft during the Second World War, 19,000 on LCVPs that put troops on the beaches at Normandy, 8,000 on LCM, Mark III mechanized landing craft, and another 9,000 in quad-pack configurations on landing craft infantry vessels. In armor, 22,000 went into M4 WWII Sherman tanks as twin-engine GM6046 double packs, producing 410 combined horsepower, and 11,000 went into M10 tank destroyers. In 1943 alone, Detroit Diesel produced 57,892 engines. The men building them worked 3 shifts, 7 days a week, in a plant running at full capacity for a war the engineers on the floor were feeding without knowing which beaches those engines would reach. After the war, the Series 71 did not stop. It went into every Greyhound bus on the American interstate system, into the semi-trucks that moved the post-war freight, into the marine workboats running the Great Lakes, and into the construction equipment that built the interstate highway system. By the time General Motors handed Detroit Diesel Division the assignment of designing a civilian pickup truck diesel, the division's engineers had more total diesel operating hours logged across more environments than any other engine group in American industry. That institutional memory was still inside the Redford Township, Michigan facility when Detroit Diesel sat down to design the 6.2-liter. The engine displaced 379 cubic inches across 8 cylinders in a 90-degree V configuration. Cast iron block, cast iron heads, built correctly for diesel duty from the first casting. Not pulled from a gasoline platform. A 21.5:1 compression ratio. The Stanadyne DB2 rotary injection pump was fully mechanical, with no electronic control module of any kind governing its operation. A diesel mechanic in a farm equipment yard can tune fuel delivery with basic hand tools because the pump responds to a screwdriver in the right adjustment port. No laptop, no dealer access, no scan tool required. Detroit Diesel's stated design objective was fuel economy. Not pulling power, not field durability, economy. The company's own advertising said the 6.2-liter had enough power for heavy pulling, then spent the rest of the page explaining how many dollars per mile it would save. Initial civilian rating, 130 horsepower at 3,600 RPM and 240 pound-feet of torque at 2,000 RPM. EPA combined rating, 23 miles per gallon, better than GM's own 4.3-liter V6 gasoline engine in the same era. The option cost $1,500. Now set that next to the IH 6.9-liter that Ford had sourced from International Harvester beginning in 1983. The 6.9-liter produced 170 horsepower, naturally aspirated. It ran gear-driven timing for both the camshaft and the injection pump. International Harvester had been manufacturing military cargo trucks for the United States Marine Corps since 1942. Their engineers designed the 6.9-liter for routes where the nearest mechanic is 60 miles behind the driver and the next one is 60 miles ahead. A timing belt fails silently before it goes. International Harvester chose gear mesh because their customers could not afford a silent failure. The 6.2-liter used a timing chain. Under sustained injection, pump shock loads that can exceed 12,000 pounds per square inch, a timing chain stretches. Stretched timing leads to broken main bearing castings, sheared crankshaft keys, and failed harmonic balances. The aftermarket eventually produced a gear drive conversion kit specifically for the 6.2-liter because the original specification was not adequate for the duty cycle the engine accumulated in the field. So why did Detroit Diesel, with 57,892 wartime engines worth of institutional knowledge, use a timing chain when the competing engine used gear drive? Because the 6.2-liter was not designed for routes where help is 60 miles away. It was designed for the Chevrolet option sheet. That is the engineering verdict every mechanic who has torn both engines down delivers within the first 5 minutes. It is accurate. It is also incomplete. Before going further, the numbers this story turns on. 57,892 Detroit diesel engines were produced in 1943 alone for Sherman tanks, D-Day landing craft, and Allied naval vessels. 379 cubic inches was the 6.2 liters displacement built from the ground up for diesel, the first purpose-built diesel in a GM civilian truck. $1,500 was the option price at a Chevrolet dealership in 1982. March 22, 1983 was the date AM General received a $1.2 billion contract to build 55,000 HMMWV CES. The standard engine for all 55,000 was the GM 6.2-liter Detroit diesel. $50 billion was GM's total plant modernization budget through the 1980s. $100 million is what Detroit Diesel Division received from that $50 billion. $842 million was Detroit Diesel's annual revenue the year GM decided to sell the company. $50 million is what GM got for it. What does an Army procurement team find when they run the same engine a farmer is using for hay deliveries through 965,606 kilometers of field testing in desert heat, Arctic snow, and rocky terrain? That answer starts in 1979. In 1979, the United States Army published a draft specification for the HMMWV, the High Mobility Multipurpose Wheeled Vehicle, intended to replace the aging M151 M8 series that had served since Vietnam. The requirements were specific: a 2,500-pound payload, 60% grade climbing capability, 60 inches of water fording depth, air transportable in units of 3 on a C-130. Hercules, and an engine that could sustain full throttle operation across desert heat, Arctic cold, and the duty cycle a combat vehicle in active service accumulates. 3 companies competed: AM General, Chrysler Defense, and Teledyne Continental. The Army ran 11 prototype vehicles across 965,606 kilometers of rocky terrain, deep sand, desert heat, and Arctic snow. That is not a laboratory test. 965,606 kilometers is approximately 600,000 miles of field evaluation, across conditions designed to find the failure point before a soldier does. AM General won on March 22, 1983. $1.2 billion was awarded for 55,000 vehicles in 15 configurations over 5 years. The standard engine was the naturally aspirated 6.2-liter Detroit Diesel 5.8. The procurement engineers who wrote that contract had the full Series 71 service history to draw from: 57,000 engines in armor at Normandy, 57,000 on landing craft, and decades of fleet, marine, and government use after the war ended. They evaluated every available diesel, ran the duty cycle, and chose the same engine a Chevrolet dealer in Wichita was selling as a fuel economy alternative to the 454 big block. The military variant was tuned differently than the dealership spec. The HMMWVs 6.2-liter produced 150 horsepower at 3,000 reach PM, 20 horsepower above the civilian rating. Under a separate program, GM built approximately 70,000 military specification CUCV trucks between 1983 and 1986, Chevrolet pickups, Blazers, ambulance bodies, and shelter carriers, all using the J-Series 6.2-liter, non-emissions, rated at 155 horsepower. AM General delivered the first HMMWVs to the U.S. Army in 1985. First combat deployment was Operation Just Cause in Panama in December 1989. The engine performed. By January 1991, Gulf War television coverage had made the Humvee silhouette one of the most recognizable military images in American history. That flat-fended profile, moving across the Kuwaiti desert in column, carried the same 6.2-liter the Chevrolet dealer had been discounting since 1982. The farmer who had optioned one into his ranch Suburban in 1983, and the soldiers driving through Baghdad in 1991 were running the same engine. Neither of them knew the other existed. By the time the HMMWV production contract closed in 2009, AM General had built 281,000 of them. The mechanics arguing about the timing chain made a legitimate engineering observation. The Army ran 600,000 miles of field evaluation and came to a different conclusion. They chose the 6.2-liter. Then they kept choosing it for 26 years. Which changes your read more? That the Army chose the Suburban's engine in the first place, or that they kept choosing it for a quarter century after the civilian mechanics had written it off? Put that in the comments. While AM General was building HMMWVs for the US Army, something else was happening inside General Motors. A spokesman for Detroit Diesel acknowledged to Financial World magazine in 1988 that in the late 1970s and early 1980s, the division had been letting bad product out the door. Market share was falling to Cummins Engine Company. Customers were not coming back. Of the $50 billion GM spent on plant modernization through the 1980s, Detroit Diesel received $100 million, not 1% of the total. 0.2%. The division that produced 57,892 engines in a single year during the war, the division whose 6.2-liter engine was at that moment powering the U.S. Army's primary light tactical vehicle, received the same fraction of GM's modernization budget that would not move a rounding figure on the company's balance sheet. By 1987, Detroit Diesel was losing $100 million per year. 5-year cumulative losses, $600 million. Revenue, $842 million annually. Heavy-duty truck market share, 3.5%. GM decided to sell. Roger Penske paid $50 million for a 60% stake. He also took a $115 million loan from General Motors Acceptance Corporation to fund ongoing operations. Penske was a race car driver and team owner whose prior connection to Detroit Diesel was a distribution agreement for New York and New Jersey. His first full year running the division, Detroit Diesel, earned $16 million on $840 million in revenue. The $100 million annual losses stopped in 12 months. Penske made no wholesale changes. The engineers who had built engines since the war years remained at their benches in Redford Township. The 6.2-liter family the Army had been building HMMWV vehicles around since 1983 was still in production. By 1993, Detroit Diesel's heavy-duty truck market share had grown from 3.5% to 33%. Annual sales reached $1.5 billion. The company ranked 269th on the Fortune 500 list that year. What Penske found when he arrived was not a division in decline. He found a division General Motors had decided was not worth the attention of a company spending $50 billion. The difference between a $100 million annual loss and a $16 million profit was not a new engine. It was management that treated the product as worth protecting. General Motors did not bring the division back. In 1993, Mercedes-Benz acquired an 11% stake in Detroit Diesel Corporation for $20 million. Daimler Chrysler acquired the company in full in 2000. General Motors replaced Detroit Diesel in its own truck line with the Duramax, engineered in collaboration with Isuzu, beginning with the 2001 model year. The division that produced 57,892 engines in 1943 for the Allied war effort, whose institutional lineage ran through Sherman tanks, D-Day landing craft, and 281,000 HMMWV vehicles, is now an asset of Daimler Trucks North America. The name has been shortened. The word diesel was eventually dropped. It is called Detroit now, and it is a German company's property. The only part of this lineage still under American ownership is AM General's General Engine Products subsidiary in Mishawaka, Indiana. They produce the 6.5-liter military variant for HMMWV vehicles still in active service. The Army's choice has outlasted every corporate arrangement General Motors ever made around the company that built it. The mechanics arguing about the timing chain are not wrong. The Army ran 600,000 miles of field evaluation and chose it anyway. That argument is not finished. If you have run a 6.2-liter Detroit diesel in a Suburban, a CUCV, a work truck, anything, put the mileage and the application in the comments. American Motor Files covers the machines that got built, the decisions that buried the companies behind them, and what those machines are still doing today. Subscribe so you don't miss what comes next.